is Nick Walsh. We're developer advocates at AWS, and this is the What's Next show. The format of the show is that we're going to go through a couple of the major announcements and the major launches that have happened on AWS over the last month. And then we go into the meat of the show, which is a section where we have 3 deep dives for you, including some demos. And they're being run by experts from the product teams that are launching these features. So it's a great time to ask them any questions that you might have within Twitch chat. And while you're doing that, we're also going to be taking a tour through the product so you have a really good sense of what this is doing, the problems that it's solving. So we hope that this is a show that we can kind of bring to you on a regular cadence, because every month there's so much happening and there's always more stuff that we can possibly cover than we can cover on stream. Nevertheless, we're going to try and make this as interactive as possible, as open as possible, really kind of looking to turn this into a conversation and take advantage of the what makes Twitch so special. Nick, are you back online with your audio?
Survey says, hopefully. We'll have to find out when someone in the stream lets me know. But
Okay.
I saw what wasn't turned on before, and I did turn it on now. So hopefully that's coming through. But we'll wait for confirmation while that's happening.
Yeah, it looks like Twitch chat says that you're good to go. So we've got it fixed.
Twitch chat, where would we be without you? You all are the best. You help us debug instantaneously. So thank you for all of that. But yeah, hi. Thank you for kicking things off, Rob. My name's Nick Walsh. I'm also developer advocate here at Amazon Web Services. We know it's a really daunting challenge to try and keep track of all of the different launches and trying to find the information that's most valuable to you. But we also know that you love being able to get hands-on with the latest and greatest launches that we have. So we're excited to have this show, to bring it to you on a monthly cadence or even more frequently than that. And we're really excited to have some deep dives later on in the show from the actual product teams that have built and launched these features. We're going to kick things off with some very quick sort of back and forths around, news that Rob and I have found really interesting. And we will then get into the demos. But I don't want to keep you all waiting. I want to let you all know what you have in store. Does that sound like a plan, Rob?
Yeah, definitely. Let's give them a preview of the demos.
Yeah, so for everyone who's already on the edge of your seats, or not yet, you will be soon. We will be joined later in the show with a demo for Global Data Store for Elasticache, as well as a deep dive on using the Amplify CLI to deploy Amplify Console apps. And lastly, Rob, what's the third one we're going through?
Oh, this is my favorite. Bottlerocket. It's a new Linux distribution for running containerized workloads. This is so cool. And we have awesome guests representing each of these products. They are going to be here to answer any questions you might have. And we also have some folks from the teams that are going to be in chat so they can answer some of your really deep technical questions or take them into one-on-one conversations. So we really hope that that the material is going to generate a lot of questions, because that's what we're here for.
Yeah, and a great call out. Again, a live show. We want to see that interaction in chat. If you have questions, please forward them along. If we can't get you an answer right now, we'd love to answer it after the show. We're trying to dual stream to Twitch on twitch.tv/AWS, where most of you are probably tuning in from and we're looking at the chat for, as well as our LinkedIn Live page, or streaming on LinkedIn Live to the Amazon Web Services LinkedIn page. So if you're joining us from either of those sites, hello, welcome, and we hope you enjoy today's content. But without further ado, why don't we get into the first set of launches that Rob and I found most interesting?
Yeah, let's do it. First up, I think you're going to be talking about Deep Composer, right?
Yeah. Exactly. So Deep Composer was a product a product with correlated services that we announced at reInvent. Matt Wood demoed it on stage by going up and playing a song on the actual piano. But essentially what Deep Composer is it is a application of GANs, generative adversarial networks, which are a class of sort of deep learning neural nets, to be able to create music from a seed input. In this case, you play music into the piano, and Deep Composer as a service will use a generative adversarial network to create a composition around it. So think if you play a melody, it will create backing tracks and percussion and so on. So you can just worry about the part that you care the most about, and everything else is auto-generated. So some really cool stuff there. Additionally, there's sort of two aspects to the Deep Composer suite, right? So we have actually pre-produced many styles that you can apply to the songs for the GAN to generate music. So if you want sort of a pop style or a funk style, those are all possible. So you can take one input and play on the piano and generate different outputs. Now, additionally, you can actually train your own. And so obviously it's difficult to sort of get up to speed with state-of-the-art GANs for audio synthesis, but two architectures in particular are available out of the box. I believe they are MuseGAN and UNet. So if you're interested in trying to generate your own theme or genre that you can then apply to new musical inputs, that's all possible. And you can export that music directly to SoundCloud. This is all available in one easy-to-use package. It's $99, and that basically includes the MIDI keyboard, although you can use any MIDI keyboard, or BYOK, bring your own keyboard, I suppose you'd call it, to provide inputs to Deep Composer. And additionally, that comes with a 3-month trial of all of the underlying machine learning services. So for $99, you get the physical hardware as well as all of the cloud resources for 3 months that would back that with a sort of on-demand pay-as-you-go or pay-for-what-you-use model going forward. And we would be remiss if we didn't mention where you could actually acquire this or purchase it. Not to the surprise of many, it's available on Amazon.com. I just threw the link in the Twitch chat for the Deep Composer. But if anyone's interested in becoming a musician, or you are a musician looking for interesting ways to synthesize new music, definitely check that out.
Yeah, and I just wanted to add that if you want to see what you can do with Deep Composer, there's a video online of Jonathan Coulton performing a piece that he composed with Deep Composer at reInvent last year. It's really cool. Check it out. Jonathan Coulton, of course, a favorite of mine for all the work he's done. It's always very nerdy, and I absolutely love his music.
Well, unfortunately, we don't have 4 musical launches, Rob, but I know there's something else that you're really interested in talking about.
Yes. So next up, I want to talk about Managed Apache Cassandra, which is now available in 18 regions in preview. And so for those of you who have heard of Apache Cassandra, you know that it's a NoSQL database. It's a column-oriented NoSQL database. And it was created by Avinash Lakshman at Facebook and open sourced back in 2008. Now, interesting fact, Avinash Lakshman is actually one of the original members of the Dynamo team, and he helped create Dynamo at Amazon back in 2004. So it will be interesting if you're a DynamoDB user to see if you can spot the similarities between these two databases. I mean, spoiler, they can both support the schemaless model of just throwing data at it. So it's part of what makes them really cool. But as with all these kinds of databases, it's one thing to kind of have this open source database that just kind of serves requests at a single node. And it's another thing altogether to deploy this database in a configuration that can really deliver the high availability and the durability that you need in production at scale. And when you add in all of the kind of the hard work that needs to go on to make that happen, it becomes very daunting to operate one of these databases. And that's what managed Apache Cassandra can do for you. It can kind of take all of the scaling, updating, and the maintenance, and it can kind of just do that for you automatically, so that all you're worried about is just using this kind of on demand. And speaking of databases, I think we have some really cool announcements around Redshift, right, Nick?
Yeah, Redshift, I know there's contention on whether you'd call it a database or like a data analytics service, or broadly, I think a lot of folks can agree that it's a data warehousing solution. And so ultimately, we have 2 big new announcements from the month of March that we want to talk about here. First being the introduction of materialized views. These are generally available, so anywhere that Redshift is currently usable, these are accessible to you. Now, materialized views are essentially separate stored views of the results of queries you've run in the past. And so Redshift automatically handles efficiently being able to store these and access them, but the way I think of them is they're kind of just like referential caches to results that can then make downstream queries even faster. And so if you aren't familiar with how Redshift is typically used, this is something that's really powerful for anything from data analysts and BI users, but even additionally to users directly working with Redshift. There are a lot of applications that are built on top of those Redshift queries, so any sort of improvements you make to the storage and accessing of those materialized views upstream become beneficial downstream. So everything from like dashboards, which obviously are also present in BI tools, but ETL, extract, transform, and load jobs and data processing, all of this sort of becomes quicker and more cost effective because you don't have to be scaling up your master on your Redshift cluster for your writes. So ultimately, yeah, it doesn't sound very, like exciting in terms of like a broad sort of like game changing feature set. But what we really see is that like anytime we can make changes so far upstream that are resulting in saved time and saved like cost ultimately at the end of the day as well, is something that every sort of user of Redshift will stand to benefit from. In an additional vein, we actually have the launch of pausing and resuming your clusters for Amazon Redshift. This is something that we've seen come to many other database solutions, or other on-demand solutions and services at AWS, but it's now available for Redshift. Essentially, what this enables you to do is take a cluster that you have, be it an on-demand cluster, where you're paying an hourly rate for that cluster. You can now pause the cluster. Typically, you'd want to do this if it's not currently processing a job, or you don't plan for it to need to immediately process a job in the future before you could turn that back on. And while your cluster is paused, you're not getting billed for the on-demand rate while that is paused. Now, obviously, when you resume, it takes a little bit of time for it to be ready to handle those jobs. But what we find is that typically customers don't have data warehousing jobs running 24/7, so that this can stand to save them money if they understand the timeline of what their workloads look like. So yeah, that's enough on Redshift. I mean, two very exciting database launches, both across Redshift and Cassandra. But I know we have a third database launch as well.
Yeah, database week over here. So our final news announcement is a bunch of features around Aurora support for Postgres compatibility. Now, Aurora is part of our relational database service. And with Aurora Postgres compatibility, what you're able to do is take your favorite Postgres client and point it directly to the Aurora endpoint. And it's as though Aurora were running on the back end. That's what Postgres compatibility means. So I'm just going to fire off a couple of these things. They're all really useful stuff, especially if you're already a Postgres user or you're considering to use Postgres for your next project. In the first place, we have in-place upgrade from Postgres 9.6 to 10. This is bringing a lot of new features with version 10 Postgres. We also have compatibility with 10.7 available in the GovCloud region. And then we have Active Directory authentication support for Aurora Postgres. Now, the last one that I want to dive in just a little bit into is Postgres compatibility with Aurora Global Database. So we have this Aurora feature called Global Database. And what we can do is any engine that runs within Aurora can basically now run inside this kind of global database mode. And what this is really similar to those of you who've used DynamoDB global tables. It's very similar to that. The idea is that you can set up one of these databases, and it basically can span across regions to provide very high availability. And ultimately, that availability becomes valuable if your application needs to survive a network partition that cordons off one region or more. But in addition, it also provides performance benefits because it means that your workloads that are reading from some of those remote regions can have lower latency. And what's really cool about this configuration is that all of the heavy lifting that you would normally have to do to set this thing up, all of the manual configuration that you have to do, we've done that for you. And not only that, in the event of one of these disasters, what can happen is that you might want to promote one of these secondary read-only regions into a primary region. And when you do that, that entire process takes less than a minute. And this is a theme that you're going to see across a lot of our storage and our caching solutions, is the ability to kind of span across multiple regions to give you a write master and a bunch of read replicas to provide this kind of high availability, improved performance. And then, of course, all of these features come with some sort of story around failover. So lots of really cool improvements in terms of Postgres compatibility support within Amazon Aurora. If you're an RDS user, you're a Postgres user, it's really worth checking out. So I highly recommend that.
Awesome. Well, I couldn't have picked a better launch to end on for the first news segment, because a lot of the sentiment that you just mentioned is going to be echoed in this first demo session. We're going to be talking a little bit here in the first demo. Again, if you're just joining us now, we'd like to reiterate, this is again AWS What's Next, where we cover all of the latest and greatest launches from the past month. So we're covering everything that launched in March here. We just covered some of the most exciting launches to Rob and I, but we are about to dive into 3 separate demo sessions with product teams that have recently launched very exciting features. We have coming up right now, global data store for Elasticache. And joining us will be Ruchita Arora, Principal Product Manager for AWS Elasticache. So sit tight. We'll be right back. And we've got an exciting demo in store for you. See you soon. All right, and we're back. Thank you for hanging in there. So, like we just mentioned, today we have the first exciting demo of the day. This is going to be Global Data Store for Amazon Elasticache. Joining us here is Ruchita Arora, Principal Product Manager for AWS Elasticache, and she's going to walk us through a little bit about why this launch is so exciting, and most importantly, show us a demo of it in action. Ruchita, thank you for taking the time to join us today.
Hey, thanks for having me, Nick.
Yeah, so briefly, could you explain a little bit about what Global Data Store is and why it's so exciting?
Certainly. So Global Data Store is a new feature that we just announced within Amazon Elasticache for Redis. And what this does is it gives you the ability to essentially have a fully managed, reliable, secure, and fast cross-region replication for Redis. So with this new feature, Elasticache Redis customers can now write their data into one region and have that data be available for reading into other regions. So that's sort of your classic active, passive, or primary, secondary setup, as you may just think of, where you have one primary region and up to 2 secondary regions to read from.
Wonderful. And this, if I have this correctly, this launch is generally available on March 16th, so just a few weeks back. And so it launched in 11 regions globally with more to follow. But this means that anyone who can actively use Elasticache in those 11 regions that this has launched in, they can now spin this up and get started with it themselves, right?
That's correct. Yes, we are available in 11 regions today, more to follow.
That's pretty cool. So could you tell us about some of the primary use cases for this feature?
Yeah, surely. So what we typically see is, two common asks around when we've been talking to customers around a need for global data store. Specifically, one, as we know, Redis is commonly used for extremely low latency reads. And so what, often customers are trying to do is, if you wanted to have low latency reads available globally, we're essentially using the geolocal reads in the region where you're kind of catering to your customers. So that's where Global Data Store fits in by providing low latency local reads. The second common sort of use case or benefit that customers talk about is your classic sort of a disaster recovery setup, where you want to architect globally and you want to just make sure that you have the resiliency in the unlikely event that either your primary or the region is degraded, not able to connect to. So then you can fail over to the secondary region and actually serve your reads and writes from the secondary region.
Yeah, so, better performance for global reads, having some sort of automated failover. This sounds like really powerful functionality. But prior to this launch, I'm curious, how did customers sort of try to achieve this?
Yeah, I think, really from what the customers have told us, there was no good sort of a good managed solution that would sort of give similar level of manageability and experience for the customers. Some of our customers have shared with us, they've tried setting up some sort of custom solution where they would essentially deploy in multiple regions, but then either try to do dual writes, or do some sort of chain replication between regions. But the loud feedback that we heard from customers was obviously this was very complex, and it was more in terms of sort of getting a reliable performance, the network issues that you have to work with, and getting sort of reliable, secure cross-region replication going, and ensuring the cross-region latency could be a challenge for some customers. That was one. The second thing, by sort of manually setting this up, issue that customers would often run into is just ongoing management, right? So that can often get very tedious. So even if you sort of set it up once, what happens if you want to now scale your clusters? If you're trying to scale your primary capacity, you want to make sure that you're effectively scaling your secondaries as well. Or another example is like the DR setup we talked about, where you want to promote your secondary region and make it a primary. Well, then how, you need to sort of manually reconfigure to ensure that your replication is now going out from the new primary region, and all the connectors are now sort of replicating from that. So there were sort of other manageability challenges besides just the first time setup, and that's sort of the feedback we heard from customers.
Yeah, so while I know that Redis has a lot of features beyond just serving as a cache, if we dive a little bit deeper into Redis as a caching solution, I know that a lot of customers put Redis in front of a database of some sort, such as DynamoDB. Can you talk a little bit about, let's say, how Redis would compare and contrast with something like DAX for DynamoDB and other database caching solutions that we have?
Sure. So DAX, if you think about it, DAX is a custom solution that's built for DynamoDB. Elasticache is a much broader solution, and we often see customers using Elasticache more broadly with multiple underlying databases. You could be using this with RDS, with DocumentDB, and that's sort of the power of where Elasticache is used. The other thing is more in terms of sort of, if you just think of the use cases that Redis is serving today, right? Specifically. So while yes, Redis is a very, very popular choice for caching and primarily for low latency reads, what we often see, the power of Redis really comes from two additional things. One is sort of the diverse data types that it supports, which actually enables Redis to serve a lot of beyond caching use cases. And I'll just touch upon a few examples. Redis comes with out-of-box support for sorted sets, right? So that's something that makes something like a leaderboard or any sort of ranking use case very, very simple and easy to get started with. So sorted or leaderboards tend to be a very popular use case. We often see Redis being used for chat and messaging or messaging and queuing sort of applications. Geospatial commands is another powerful support that Redis comes with, inbuilt support. So think of your classic sort of ride-hailing applications where you're trying to match a driver and a rider, and you just want to find the nearest driver. So there are a lot of inbuilt sophisticated data structures that Redis comes with that kind of really lends itself well to a lot of beyond caching use cases. And so what we see is a good way to sort of summarize this is anywhere where you need real-time analysis or real-time performance, we see Redis being used extensively, right? And this is across industries, whether it's gaming, media streaming, just a variety of ad tech, just a variety of verticals.
Yeah. Well, speaking of these real-time applications, I know that one very popular architectural style for powering real-time interactions is the pub/sub pattern. And this is one of the most common use cases for Redis. And if I understand correctly, what you're saying is with the conjunction of this feature and this data structure in Redis, really, plus the global data store solution, what we have essentially is a very easy way to get up and running with a Redis cluster that spans multiple regions that can provide a pub/sub system, is essentially a global pub/sub system on demand.
Yes, that's a good way to think of it as well, right? Because pub/sub is a very popular choice. Also, just to go a little bit deeper on that, within Elasticache, we support two configurations for Redis. One is sort of your very simple, you have one primary node or your master node and up to 5 replicas. And the other one, what we call the cluster mode, which is nothing but you're sharding and you have multiple partitions or multiple masters within a region. And you're kind of distributing or partitioning your data. So the pub/sub model with global data store works really well with as long as you're within the context of one shard. So a classic configuration where you just have one master works really well. Or if you're just going to try to do some sort of pub/sub within a particular shard.
Awesome. So when it comes to like cross-region replication, what does the latency look like there?
Yeah. So the latency that we typically that we've seen, and we're supporting multiple commercial regions within AWS with Global Data Store, but we typically see under a second. So it's very, very quick. And a good way to think about it is if you've noticed any cross-region latency within AWS, it's very, very close to that.
Great. We actually also have a question from LinkedIn Live here that we'll be asking. From failing over to a secondary region, what does that look like for read latency from the local region? So assume one region goes down, it fails over a second region, and the initial region comes back up. Like, what does the read latency look like there?
Right. So I think there are two aspects. One is, when the failover is happening, and obviously that transition period is going to, that's just something you need to take into account for. But once you initiate the failover, it's a single click or a single API that you use to do that. And the failover typically happens within under a minute. In terms of the actual read latency for any region, the only thing you want to make sure is when the transition happens, the data needs to sync from the new primary. So there's going to be some initial sync that depends on your data volume and the incoming rate. But once that's done, locally you're just talking about the Redis sub-millisecond read latency.
So I know that there's a lot of solutions that we build to secure data at the database layer, but we don't often talk about how that extends to the cache layer, especially when you say that the cache layer can span a polyglot set of databases that you're using on the back. Can you talk a little bit about some of the security features, either with respect to the replication or with respect to the data at rest, and what kind of security features we have there?
Sure. I'll answer that in two parts. So by default, just outside of global data store, in Elasticache for Redis, we have support for both encryption in transit and encryption at rest. So if you're just local within a particular region, you can still enable these encryption capabilities. And this takes care of encrypting any sort of node-to-node communication or any in-transit communication, as well as if you're enabling encryption at rest, then your data, any data that goes on disk or at rest does get encrypted. We also have support for customer managed CMKs or master keys for encryption at rest. So this is something that's available locally in each region. Now, in addition to this, when we set up a global data store and you have cross-region replication happening, by default, Elasticache enables encryption in transit for the cross-region communication. So cross-region communication secure by default, and on top of it, customers have the choice to enable locally encryption in transit or rest.
That's awesome.
Yeah, so I mean, I'd imagine a world where I can go into the console and just create one of these new global data stores, right? But what if I already have existing clusters? Can I upgrade them to leverage global data store?
Yes, we actually support setting up a global data store with a new primary cluster or an existing cluster. The only thing you want to make sure is when you are using an existing cluster, you are on the latest engine version, which is the Redis 5.06 version that we support today within Elasticache. So as long as you're on the latest, you can use a new or existing cluster for setting up a global data store.
Wonderful. Well, I know I love seeing these things in action more than I like just talking or hearing about them. Is there any chance we could get a demo or see this in action?
Yeah, certainly. Let me do that. I think this is a good segue. I'll try to show the global data store with an existing cluster. Okay, perfect. Can you guys see my screen?
Yeah.
Awesome. So I did kind of do a video capture, but what I really want to talk about here is how do we sort of set up a global data store using an existing cluster we just talked about. And then we'll quickly go and test the cross-region replication and close off by sort of looking at some of the operations that are supported on the global data store. So with that, I'm going to actually move to the Elasticache console. And what you see here is I'm already logged in the console, and I'm in US East 1. So that's sort of what you're seeing here. And on the screen, I'm in the list view where I can see all of my existing clusters within US East. So I'm just going to go pick one of my existing sandbox environments. As you can see, this is on 5.06 version, Redis 5.06. So that's the minimum version that I need to use. And then I'm using the R5 large nodes that are also supported with global data store. So with that, I'll select it and I'll go to actions to set up a global data store. So once I come in here, there are a couple of new fields. I have to give sort of a description and name for the global data store that will be created. Notice this is actually not the full name of the data store. The name would be auto, but I'm providing a suffix. And then I go and I pick my target region or region, right? Again, so I'm starting with the primary region, which will accept writes, and then I'm setting up a secondary region, which will accept reads. So I'm going to pick US West 2 here. And then I go in and give, what you see below here is just a classic cluster creation within Elasticache. So once I've selected my region, I'm going to give a name for the secondary cluster. So sandbox copy is going to be my actual secondary cluster that gets created. Rest of the fields are pretty standard. If you are an existing Elasticache users, this is something that you're already familiar with. I'll not go through all of these, but just call out attention to a couple of differences that you might notice. Pay attention to the engine version, the parameter group, and the node type. And these fields are auto-populated by Global Data Store to make sure that the settings on the secondary cluster exactly match the primary. So that's something you don't have to worry about. So once I go ahead create, I get redirected to the global store page. And as you can see, the sandbox global data store that I just started creating is now showing up here. Just for the purpose of demo, it's going to take a couple minutes. So for the purpose of demo, I'm going to use a pre-created global data store to sort of through some of the other details. So I have an existing data store, which is again between the two same regions. I set it up between US East 1 and West 2. Notice my primary region is same as US East 1. So that's where I'll send my writes later. And this is available so I can kind of go through the details. So just some of basic details at the top. And then right at the bottom is actually in the regions that debate, along with the actual cluster names. So these are hyperlinks, so you can actually also redirect to view the details of those local regional clusters. And that way you can kind of navigate back and forth. And my US East 1 is the primary, where I'll send writes. And US West 2 is the secondary. So with that, let me kind of go and actually do a test, right? Let's just go and write to the primary region. So what I have here is I've sort of set up my terminal already. On the left side, I will actually, the windows on the left, I'll use to connect to the primary region. On the right, I will connect to the secondary region. So just keep that in mind. Okay, so let's do a quick connect. Connecting to US East. And I have two windows on the left. I also want to show you local replication happening within USC. So just that way you have some context. Okay, so I'm going to connect to one of the shards in US East 1. So that's going to be my primary node where I'll send my writes. And then at the bottom, I'm going to connect to the local replica in US East 1. So local replica is typically something you would use for, like a multi-AZ setup or an auto failover within the region. And then here going on the right, I'm connecting to US West. And then I'll actually get into connecting to one of the nodes in US West. What I want to make sure here is I'll actually quickly show you that both the replicas that I'm connecting to, the local replica and the remote replica, are indeed replicating from the primary node where I'll write. So let's do a info replication. They shows that it's replicating from the node, the IP that's highlighted, and then same thing on the remote region, which is my secondary region. It's again replicating from that node. Okay, with that, I can set some values on my primary region. There you go. Just a quick check locally. So I can see my current values in the primary region. Now I'm going to do the same thing on the secondary region. You see the values show up in US West. Just to do this again, right, I'm going to change the values and see how quickly it shows up. And I'll do this remotely first, so we can just do a quick get. There you go. So the values that I said, they're all showing up remotely. This is all instantaneous. For completeness, doing the same thing locally. So that's sort of, as quickly as you can, just writing into your primary region and making sure that you can read from the region. All right, so with that, let's kind of go and look at some of the operations that are supported on the global data store. I'll show you just basic operations. How do I modify? How do I scale? Now I have this global data store that works perfectly seamlessly. If I wanted to sort of scale this, so what I'm showing here is, remember we started with the R5 large node types. So if I just want to kind of scale, I can go pick a larger node type and sort of scale up. That's one way to scale. And here you notice that this impacts all the participating clusters. So if I'm scaling, all the regional clusters will actually scale so that the configuration stays the same. Another mode of scaling within Elasticache is scaling in and out, right? So that's kind of where you would add shards or remove shards. So I won't go through all of those operations, but essentially those are all available centrally as a one-click experience within Global Data Store. So you can add shards, delete shards to scale horizontally. And again, this operation would make all the participating regions and clusters stay consistent. Lastly, I want to kind of talk about global data store or regional operations per se. So you can see I have right now just two regions participating in the global data store, one primary and one secondary. As I said earlier, with this release, we are supporting up to 2 secondary regions. So I can go and actually add one more, right? So it shows me that, hey, you already have 2 regions as a part of this global data store. I can go pick another secondary if I just want to do that. Go through it, but this screen looks exactly the same as what we started with. So just something where you can sort of come and after the fact add another secondary region. I won't do that right now. Couple other things. If you wanted to sort of remove your secondary region, you can just come in and quickly remove a secondary region as well. When you do that, it'll actually warn you to say, hey, this is your last secondary region that you'd be removing, and the status would transit to a primary only. You kind of know that there's no secondary or no secondary copy for this cluster. So finally, the most important things, right? How do you kind of promote the secondary region to primary? So if I wanted to make US West now to be my new primary region, I just go select that and promote to primary. And what's telling me is US East 1 will stop accepting writes. It'll actually get demoted to become the secondary, assuming we can actually connect to US East 1. So that's sort of, pretty much the last operation I want to talk about. This is pretty quick. It takes less than a minute to actually finish the promotion. So just kind of summarizing for you everything we went through, right? We set up a global data store using cluster and then looked at the operations. Now, you don't always have to use an existing cluster like we talked about earlier. You could just set up a new primary cluster as well. That's something we've talked about in a blog, so feel free to just actually go and look at the blog. Yeah, we will be doing more of these sessions and for the global data stores, so feel free to keep an eye and join us for more.
Awesome. Well, Ruchita, thank you so much. That was really amazing. So, sort of in conclusion here, if you are a Elasticache for Redis user, you can try setting up global data store yourself for existing clusters, as you showed in the demo right there, where you also mentioned if you want to spin up your own new cluster, that you can very easily set global data store up there. It's its own sort of standalone entity inside of the Elasticache suite of services and features, and you can hook this up to all the clusters that you already have running for global read replicas and failover and all the wonderful things that you just spoke about. Awesome.
Yeah. Thank you so much. That was an excellent demo. I really like how simple and how simply presented all of the different features are. I mean, under the covers, there's a significant amount of complexity that's going on here, and it's just front and center in the console like that. Promote to master, add a new region. It's all just very impressive. Thank you for the demo.
Thank you.
Awesome. Well, to everyone out there in the audience on Twitch and LinkedIn Live, this is demo 1 of 3 today. We are going to be right back while we get lined up with our second guest. But hang tight, we'll be right back, and we'll be dropping some of the links for Global Data Store in chat during the intermission. Thank you, be back in just a minute. All right, hey everyone, we are back. We have another exciting demo lined up. This one here is going to be in the realm of AWS Amplify. In particular, we're going to be talking about a very exciting new feature launch, which is going to be using the Amplify CLI to launch and host Amplify Console applications. But I don't want to steal his thunder too much. First, let's introduce our guest, Nikhil Swaminathan, Senior Product Manager for AWS Amplify. Nikhil, thank you for joining us.
Thanks for having me.
Hey, Nikhil, welcome.
Hey, guys.
Yeah, so this is an exciting launch to me. I'm an Amplify user myself. I've used both the CLI and the console experience. Can you walk us through a little bit about what this launch is and how it's uniting the CLI and the console?
Sure. Just to kind of take a step back, let me maybe talk about what the Amplify Console offers. So the Amplify Console offers hosting for modern web apps. So that's modern web apps include SPAs built with like frameworks such as React, Angular, and Vue, and static site generators such as Gatsby. So the Amplify CLI is a tool developers install on their local machines to provision backend services in AWS. So you can run commands like amplify add auth, and we automatically generate a CloudFormation template. And you run amplify push, and that deploys that template to the cloud. So when the Amplify CLI launched 2 years ago, there was a hosting category that the Amplify Console has finally integrated with, because we launched Amplify Console about a year later. And that's what this feature is really about. So today, when customers now run Amplify head hosting directly from the CLI, they're able to set up hosting with Amplify Console instantly.
Yeah, so like broadly, this is very exciting. Getting set up with hosting with static sites, just like you described. Like, what does hosting with the Amplify Console look like currently? I know the CLI is going to enable us to do that, but what is sort of the ground truth look like here?
Yeah, so hosting with Amplify, so under it's a fully managed hosting service for one. So under the covers, we're powered by CloudFront, but we're not actually exposing the CloudFront distribution to the end customer. That allows us to offer functionality such as instant cache invalidation. We have an easy redirect process. So you've got redirect set up for your old site and your new site. You can set them up. Password protection, custom headers. So we've really kind of looked at the use cases of what modern app developers or web app developers have, and we've kind of focused on building an experience that just simplifies it for them. And the other feature, it's not a hosting feature necessarily, but it's really like it ties in with our hosting, is our continuous deployment offering. So what you can do is you can connect your Git repository so that you could be hosting your code on GitHub, Code Commit, GitLab, or Bitbucket. We automatically detect your build settings, and then we basically deploy your app, and that's it. And what customers have really loved about what we have is how easy it is to actually get up and running with a production-grade application.
So you mentioned this is operating on top of CloudFront. Can you walk us through, before some of this integration came along, some of this automation came along, what would it have looked like for somebody to go into AWS and build this infrastructure themselves?
Yeah, sure. So I mean, I think it's all about control, really, right? Like, if people were kind of building this themselves, you would first set up like an S3 bucket where you would host your static assets. And then, with that S3 bucket, you will link that to a CloudFront distribution, and then you would have to think about how, a second S3 bucket for your naked domain. So, because the moment you hook up a custom domain, then it would become a little more complicated. And then for redirects, there's some redirect functionality available in S3 and some available in CloudFront. And then Lambda at Edge actually made a lot of kind of improvements in that area, so people could use Lambda at Edge to manage their redirect settings. So really, what we found is that there were a lot of steps for customers to get a static app hosted on AWS. And from talking to customers, they loved what CloudFront had to offer. There were a lot of friction points in actually getting their app up and running, and that's what we kind of aim to simplify with Amplify hosting.
Yeah, and
Awesome.
you mentioned before that this is tailor-built for modern web apps, and you just referenced traditional web apps there. Could you walk us through sort of the difference between the two and where Amplify sort of comes in here?
Sure. So let's go back like maybe 10 years now. Yeah, sorry, 10 years in time. Server-rendered web apps were kind of the most common approach to web development. So you have your browser and you have your server. Every incoming request from the browser was handled by like a server-side language, which then parsed the request and then fetched the data from the database and returned all the assets that the browser would then load. So that would be HTML. Basically, it would be HTML, CSS assets that would eventually get loaded by the browser. Now, what this would mean is, let's say you're on a product list page and you click next. That request would go to the server. The server would fetch all the assets required and return that to the client. So with the popularity of JavaScript frameworks, that kind of changed everything. So it kind of flipped. It's kind of the inverse now, where what happens is the browser sends a request to the browser sends a request to the server. The server returns a simple index HTML file with JavaScript in the client, which actually handles a lot of the logic on client-side routing as well as like state management. So a lot of the complexity that used to be handled in the back end is now handled in the front end. And what that enables native mobile-like experiences. So if you're on an app that is an SPA or a static or like a statically generated one, where you click on a link, your page your refresh will almost occur like you're navigating in your native mobile app. So I think that's been one of the major advancements we've had in the last 10 years with modern apps, web apps specifically, and that's kind of the core customer base, people building those web apps. The Amplify Console aims to serve.
Yeah, so we mentioned that in this demo or this new launch, we're talking about how the Amplify CLI is enabling folks to launch console applications. Can we talk very briefly about how they work together? Because I know we'll see that more in the demo, but let's give folks a little bit of a primer there.
Sure. So today, when you actually start in the CLI, so let's say when you install the CLI locally and you initialize a new project, you're actually able to see your backend resources in the Amplify console. What you were not able to do is actually, once you've got your web app working locally, deploy that front end to the hosting offering available in the Amplify console. So that's essentially the functionality that we've had, because we developers were working. As a developer, when you're working locally, and you want to be able to access commands directly from your command line window. So the CLI had an ad hosting functionality available with CloudFront and S3 previously at launch, and what we did is we added the hosting with Amplify option in. Some might say it was a long time coming.
So you mentioned that earlier we have Amplify is actually quite an extensive suite of tools for mobile and web developers. Can you kind of situate us and give us a quick overview of where this fits in with the rest of what Amplify offers?
Sure. So in terms of what products we have client libraries, we have the CLI, and then we have the console. Now these client libraries are so the CLI. I'll start with the CLI. The CLI is kind of where you get started with Amplify. It's you're building a new app and you need services like authentication data. You'd install the CLI, run commands like amplify auth, amplify API, and we'd spin up GraphQL APIs, Dynamo tables, Cognito user pools, which is our AWS's authentication service. And you would now have cloud resources that you could connect to in the cloud. Now what you would do as a developer is that you would add these client libraries. So these libraries are what make calls to your backend from your front end application. So you'd put a library in, and then you do something. You'd call like auth.signin, and then you'd be able to make calls to backend AWS services. And so the difference between the libraries and the raw AWS SDK APIs is that the libraries are all use case based. So we've looked at what are the common use cases people are trying to do when they're trying to build an application, what around like auth specifically, right? And we've built our API interface based on those use cases. So now once you've built that entire application, so it's a full stack app basically. Your front end is, let's say, your React or Angular or mobile app, and then your back end is what's in the cloud. You can then take that, connect your entire repository to the Amplify console and set up a continuous deployment workflow to actually release your application. So the Amplify console kind of offers this workflow for developers while they're building features, being able to build new features while you're shipping a production version of your app, and then the ability to build new features without impacting what's in production. We've really kind of built a lot of functionality that enables developers fitting in with their common workflows. So for example, we have feature branch deployments where customers can connect their master branch and their dev branch, and they automatically get, as I'll show you in the demo, two separate versions of two separate full stack applications. So they have a master.yourapp.com and dev.yourapp.com. And we've also kind of simplified the custom domain workflow. So if you are bringing your custom domain over, if you're managing it in Route 53, all you would do is you would go add domain, and then you would see your domain, and you would see you see a drop down with your list of domains. You hit save, and we automatically generate like an SSL cert for you, as well as hook up the custom domain. So then and set up redirects. So let's say you're Robert, you're at you have robert.com. We'd set up www.robert.com and robert.com and point robert.com to www, so that when your users come, they're navigated to one place. And you can obviously modify these redirects as well.
Yeah.
One thing I was going to say is, to be very blunt, when I think Amplify, I think how much easier it makes my life, right? Like, there's all these different sort of workflows that your team has analyzed and tried to boil down to be as simple as possible. To be quite frank, it's like adding auth is as simple as writing in the CLI, Amplify add auth, or Amplify add analytics, or Amplify add, whatever, right? Like a database. I know that when I see Amplify in action, that makes it all the more tangible for me. And we already have people in chat that are just like, please let me see it. Do you think we could get a little bit of a showcase of what it looks like to use this?
Yeah, of course. Let me share my screen here. All right, I'm doing a live demo, guys. So wish me luck.
Wish him luck, Twitch chat.
Yeah, good.
All right. So what I have here, for the interest of time, I already started with an application that does a basic to-do app, and it's completely local right now. So this is in-flight test during the Twitch stream. We create that. All right, great. So this is an example of a modern app, right? This is a React app where the backend was created by the CLI. So what I had done is actually just before this demo was run Amplify add API, and that deployed a GraphQL API to the cloud as well as a NoSQL database. So I'll show you that very shortly as I kind of deploy this to the cloud. So now let's say I've built this great to-do app, and I'm ready to push it to my end users. So I can just go to the CLI. Let me just make this bigger. If we go to the CLI, run Amplify at hosting.
Hold on, I don't know if we can see your CLI. I don't know if it's on a different monitor or something.
Okay, let me reshare. Let me just restart the share. There, can you see my CLI now?
Yep, you're good.
Okay, perfect. Yeah, sorry about that. So I ran Amplify at hosting, and now I have two options. So I have I can host with Amplify console, or I can host with Amazon CloudFront and S3. So CloudFront and S3, I mean, the way you would make this decision is really about control. CloudFront and S3 is more of a do-it-yourself approach, where you can use CloudFront and S3 to spin up a CloudFront distribution that you manage, whereas over here we manage it for you. So I choose hosting with Amplify console.
So what's happening under the hood here while this command runs?
So under the hood right now, the command, while the command's running, it's fetching information from the cloud to see if something's already set up or not. But really, we have two options here. So we have continuous deployments or we have manual deployments. So continuous deployments are the Git-based deployments I was talking about. So this would require me connecting my repository. Manual deployment is, let's say I'm just building a test app and I just want to get something on the cloud to make it shareable with you guys on the call. I could just easily just do a manual deployment. That means I'm not committed my code to Git. It's kind of a friction-free process of getting a website up and running. But just for this demo, I think I'd like to demo the continuous deployment workflow because I personally think it's pretty cool. So what this will do is that it'll open up the amp. Sorry, 1 second.
All good. Type on Amplify. Yeah. While you're setting this up, I was going to say I've been a user of the Git-based deployment CI/CD pattern for in the console for a while, and I've been waiting for this feature to get launched on the CLI. So I'm excited to see this in action because of just how easy it is to keep my apps updated, to just auto rebuild from master, for example.
Right. So while that happens, actually, I'll show you what would have happened is that it actually opens the Amplify console. So this is the Amplify console, and this is the same app this is the same app for which the backend for which I had deployed. So I'd called the backend prod, and I have an API in there. So I have, if you look at this backend, all I've deployed so far is an API with a to-do table. And let me actually connect my front end first. So I connect my GitHub repository.
So while you're typing in that auth code, essentially what Amplify is going to do is it's going to ask you for permission to integrate with your repository so it can remain private as well, and it can automatically pull those latest commits in from master.
Yeah, one of the cool things is we don't actually store any information about your repository. So like all we do is we put a deploy key, so we can get new commit triggers, but we can't do things like write to your repository, and we only have read access to your repository. So I've already committed this repository to GitHub. So basically, all I do is I pick the repository, I pick my branch, I hit next. So some of the things, the nice stuff we do that customers really like is that we automatically detect. We inspect your repository and automatically detect that it's a React app and that you've already set up a backend with Amplify. And what I can do now is I can deploy updates to my backend resources and my front-end resources together on every code commit. So we're not really differentiating between what's in the backend and what's in the cloud in the front end. So this will allow you to set up CI/CD workflows where you're working on your dev branch. Let's say you add new functionality in the backend. You just merge that functionality to master, and the updates will automatically roll out. So let's just say I want to deploy updates with prod together. And all the build settings are automatically detected, so you don't really have to do anything. Sorry, I need a service role. And the service role enables the Amplify console to deploy resources on your behalf at build time. And now what you'll see here is a continuous deployment process has kicked off. Which has 4 stages. There's a provision, build, deploy, and verify stage. So while this will build, so what we're doing is we're spinning up a container right now, and once the build runs, the build commands will execute there. For test, what we have is we have an integration with Cypress. So let's say Cypress is an end-to-end testing framework. So if if you're building new features and you want to have end-to-end tests, which I highly recommend before shipping to production, you could have your tests here, and we have like a nice UI so you could see your test results as well, and make sure you catch any regressions before they go to prod. So while this is building, I'm actually going to show you the production backend that I had deployed, and I made calls to from my local host. So if I go to this to my Dynamo table here, I should see 2 entries. one for pre-demo and one for in-flight.
So let's just pause here for a second. I see that we've been rated by CS Lectures. Thank you. For those of you who are just joining us, we're in the middle of our second demo of the day with Nikhil from the AWS Amplify team. What he's showing us right now is the experience of using the Amplify CLI in conjunction with the Amplify Console. The idea is that when you install the CLI from NPM, you can then generate an application, test it locally, and then what we're seeing here is the database that's generated when you add an API endpoint to your application. Did I get all that right, Nikhil?
Yeah, pretty much. So what you would notice here is like I have two different to-dos. This is the to-do I just created during the Twitch stream, and this is the one I created right before the stream, and I created all that from localhost. So now, when this deployment completes, I'll show you how I can create one from here as well. But while that's happening, I just wanted to walk through like the domain management feature.
By the way, I love how you have the GraphQL underscore type name inside the table.
Say that again.
Inside your DynamoDB table, how you have the GraphQL underscore type name inside your. It's just a little bit of GraphQL leaking into the database.
Yeah. We're pretty GraphQL heavy focused here.
Yeah. Hey, that's a good thing.
Yeah. So for the domain management flow, how this would work is I have a hosted zone in my Route 53 account. That's a website that I have that's actually in production right now. But I'm just for the purposes of the demo, I can show you how easy it is to set up. So all I would do is I'd say I'd point my domain to this branch, and here I set up the redirect from my root domain to my www domain. Now I will hit save, but then I will delete it right away because I don't want it to go through. But I'm hitting save to kind of show you what that workflow looks like. So this will generate an SSL certificate. It'll verify it, and then your domain will get active. This typically can take anywhere between 2 to 12 hours, depending on depending on like some of the verification process of the domain. Because in order to generate a SSL cert, we need to verify that there's the domain, that you own that domain. And if you manage it in Route 53, this happens automatically for you. If you're using something like GoDaddy or you've bought a domain elsewhere, any third-party domain provider, you're going to have to enter that DNS information in there. Another feature that I really like is like the previous feature. This is one we launched last year. So how this works is that for this repository, for every pull request that's generated, we automatically spin up a new site. So that way, if you wanna, and I can maybe show you an example of what that looks like on our, because we're using it for our new docs site. We have our AWS Amplify docs, and we're using it for our new doc site. So if I look at some pull requests, there's one right here. So if someone submits a pull request for a particular feature, in order to actually see how it works, we actually generate a preview. So this is not impacting your production site at all, but everyone on the team, all different stakeholders, can actually then click on that PR and see how that PR looks, if there are any bugs, and you want to just play around with it. So that's one of my favorite features of what we have with Amplify. And then, all right, so this is all done. So let's actually go ahead and create a
Yeah, that is such a cool feature. I think you really kind of understated just how cool it is and how powerful it is, because when you take a feature like that generates a branch and generates a deployment based off of a branch, you can actually combine that with a lot of tricks on the front end too. Like say, for example, if you're building a hybrid web application or you have something like a web view as your mobile application or PWA or something, what you can do there is you can have a configuration file that's like, let's say it's kind of like a feature toggle. And it says, am I on the master branch? Am I using the production version, or have I opted in for the beta branch, right? And you can have this kind of deployment pipeline, and then you can have your users segmented between production and beta, and then you can see like, well, we're getting a lot of bug reports on the latest beta push. Let's go fix those before we push that into production, right? So what you're showing here, I think, are the building blocks of a really sophisticated end-to-end pre-production pipeline.
Yeah, absolutely. And I think one of it's one of the use cases we hear a lot from customers as well, wanting to like set up like split testing setups where you can start rolling out traffic. I mean, that's not something we have right away, but I think you can configure the setup we have right now to enable that. So yeah, so just confirming that this record got created. Let's actually refresh this. And here you go. So this was the demo. This is what I created here right now, the demo in the Amplify console. And very quickly, I just want to show you how easy it is. I won't actually wait till it deploys, but I'll just show you how easy it is. Let's say I have my dev branch now. I say, okay, connect my dev branch, and now what I can do is actually create a new backend environment for that dev branch. So I'll call it staging. And I hit next. And save and deploy. And now the reason, so this will actually create a completely new front end and back end. So now what's going to happen when this pipeline is a new Dynamo table is going to spin up, a new GraphQL API endpoint is going to spin up. So now what you have is you have your master and dev set up, and these are two completely different environments. And as this provisions, I think once the build starts, you'll see that a new backend here called dev will show up. Now, I think I kind of brushed over this, but the reason we can do this is because the way the Amplify CLI works is that everything it creates is a CloudFormation template. So for those of you not familiar with CloudFormation is a mechanism to define your backend infrastructure as code. So you can create repeatable units. So if I go into this Amplify folder here, I had added API. So what you'll see is that my API here has a CloudFormation stack. This is a custom resource we have, but there's a CloudFormation stack that actually is, and these are the parameters to my stack that we use as a reference to actually deploy the backend. And that's kind of how we're able to do this here. We're able to create a completely new unit. It's because the CLI generates everything as CloudFormation.
We actually have a good question from Twitch chat here from AA Not. Can the Amplify storage, in this example, I assume they're talking about like the Dynamo table that gets spun up, can that be accessed by other applications?
So you mean other Amplify applications, or?
I guess broadly, like non-Amplify applications or just Amplify applications?
Yeah, 100%, because I think what we're doing is we're actually, so all the backend functionality is actually deployed in your account. So we only manage the front end. So everything here is actually, so this API endpoint, so if I go to the API endpoint, so there's a GraphQL API. This API will be available in your console. So you will be able to manipulate this you'll be able to access this resource and connect it to connect other data sources, and you can use the same data source with like multiple apps as well.
Awesome. Well, this is great. I mean, I've used both the CLI and the console before for Amplify, and being able to see sort of the CLI getting married closer and closer to the console so that folks can access similar very powerful functionality on both is something that I'm excited about. I'm gonna, right after the stream's over, go in and figure out how I can integrate this with my apps that I have deployed with Amplify.
Awesome. Yeah, so let me just quickly see. Yep. So you see a staging backend has gone created. Once that build completes, I promise you'll see new infrastructure, because I have an old app which I demoed, which will have that backend. So there you can see there's a staging backend with its own backend, and you spun it up basically by a couple of clicks.
Yeah, and that pretty much addresses the question of, does your staging branch have to use production data, right?
Yes, correct.
Yeah, so it seems like you can have it both ways. That's awesome. I also want to give a shout out to one of it's a kind of a simple feature, I guess, but it's really useful. Because you mentioned earlier that you guys have your own, you kind of use CloudFormation under the covers. But for those of you who've used CloudFormation, one of the first things you hit is this propagation delay for deploying a new CloudFront distribution.
CloudFront.
Yeah, CloudFront. I meant CloudFront.
Yeah.
And so that propagation delay can actually take a while, because as a CDN, CloudFront actually spans our entire Amazon global network of POPs and edge locations, right? Because the idea is to serve the data from the closest location to the client as possible. And as a result, CloudFront actually has to go and do a lot of work in order to get that distribution set up for you. And we were talking offline, but it sounds, what you guys did was really cool, because it sounds like what you're doing is you basically pre-warmed this distribution. And
we have a warming pool of CloudFront distributions. So when you create an app in Amplify Console, that distribution's already warmed. So you don't have to go through the process of waiting for that propagation delay. So once your site is deployed, it's available everywhere.
I'll go out on a limb and say Amplify is worth using it. The only thing it did was reduce distribution delay on CloudFront. But of course, it does so much more than that, right?
Yeah, I hope so.
All right. Well, I think we are running up against the clock here for this session. But Nikhil, thank you so much for your time. This has been an amazing demo. I know lots of folks in the chat are excited to start using this. I believe if folks want to get started with some of these features, we'll throw a link in chat, but that URL is going to be console.amplify.aws. Again, Nikhil from the AWS Amplify team to show us the newest feature launch, which is launching console apps from the Amplify CLI. Awesome. Well, hang tight. We'll be right back. We have the third demo of the day, and this one you won't want to miss. So hang tight. We'll be right back in just a moment. On to the wire here on our last demo of the day. For those that are just tuning in, again, this is AWS What's Next, the show where we talk about all of the latest and greatest launches and newest features from the products and service teams here at AWS. Joining us for this very exciting session on Bottlerocket is Samartha Chandrashekar, product manager for Bottlerocket. Samartha, thank you for joining us.
Hello, folks. Great to be here, and great to put Bottlerocket in the hands of our customers. It's been we've been working on it for a while, so it's super exciting.
Welcome, Samartha. Thanks for being here.
Likewise.
Yeah, so you said that it's something customers have been waiting for a while, but for those that aren't familiar or haven't followed the launch so far, which is probably most folks at home, can you tell us a little bit about Bottlerocket?
Certainly. So Bottlerocket is a brand new open source Linux distribution that is purpose-built from the ground up for the sole purposes of running containers. In fact, the only thing that it can run is containers. And because we've taken such an opinionated perspective on what it can run, we've been able to sort of hit certain sweet spots in that trade-off spectrum and sort of hyper-optimize it for just that one use case. And that's what Bottlerocket is. It is built around being able to allow customers to automate their container infrastructure deployments, around being able to reduce the operational work involved in maintaining your container infrastructure, to keep it up to date and keep it secure. It integrates with container orchestrators such as Kubernetes. ECS support is coming soon, etc. And the best part is that it is built as an open source project on GitHub. The project's going great. There is a distinct difference between sort of the AWS provided builds that are optimized for use in EC2, and then there is the open source project itself, which has a broader charter. We encourage everyone on the stream to go check out the open source project and the product. Try out the AMI. Got pull requests, submit, make your contributions. All of that.
Samartha, I'm going to have to stop you right there. You just said we launched an operating system, right? Bottlerocket's an OS. Where does this slot in? I know you mentioned it works with ECS, it works with EKS, but what is the primary motivation for this dedicated purpose-built operating system for running containers?
Certainly. So if you look at, let me take a step back. So we as AWS have run containers on behalf of customers, as well as helped customers run containers in EC2 instances for a while now. And there are a bunch of learnings that we've gotten as a result of that. And Bottlerocket includes very many of these learnings, and it's a manifestation of all of that. Now, the best way to sort of answer that question, in my view, is to contrast it with a traditional general purpose operating system like Amazon Linux. There are plenty others of that nature. If you look at something like Amazon Linux, which is a general purpose operating system, as opposed to Bottlerocket, which is sort of hyper optimized just for running containers, Amazon Linux, the core constituent building block of the OS is a package. And then there is a package manager. It's called the Yum, which is surprisingly short for Yellow Dog Updater Modified, although people just call it Yum right now. And it uses RPM packages. And essentially, there are these complex dependencies between these packages that this package manager tracks. So when you go ahead and attempt to update the OS using a package manager like Yum, there are a whole bunch of these package dependencies that get sorted out before an update is sort of reconciled and actually applied. However, if you look at most general purpose OSs, the number of packages is so very large that the dependencies are gnarly and complex. And as a result, it is not uncommon to run into botched updates where the package dependencies are not able to get resolved. And as a result, it's very hard to automate some things when things fail in unique ways each time. So oftentimes people have to go in and manually remediate these botched updates. It's not possible to roll things back, etc. So that's one of the areas where Bottlerocket comes in. And it helps reduce uptime and improve operations by allowing you to easily and quickly automate OS updates by making the update process itself super deterministic. In Bottlerocket, each update is a single-step process. So it's an atomic or a transactional update, as we call it. And it also provides for the ability to roll back that update if for whatever reason you want to go back to the previous state. And it also tightly integrates with orchestration systems. So when you're running a large cluster or a large fleet of OSs, you don't really have to sort of write your own automation for the OS update process itself. You can just do that from the orchestrator, and that is one of the other benefits that Bottlerocket provides. Lastly, a general purpose OS is aimed at supporting a plethora of workloads. It could be databases, it could be containers, it could be lots of other apps with lots of different packaging modalities. The container model itself lends itself uniquely to an OS like Bottlerocket because it helps decouple the application from the OS in many ways. So the app, along with all of its dependencies, are bundled into this container, and there is sort of a standardized interface between the container and the OS. And Bottlerocket takes advantage of that, and it includes some, in combination with features like read-only root file systems and things like that, as opposed to following the older general purpose OS model of being able to customize each OS instance for its workload. Bottlerocket allows you to automate your infrastructure with a certain degree of consistency, and that read-only root file system prevents a lot of drift in sort of the core host OS itself. So that is at least one pivot around sort of the differences right there.
So you mentioned orchestrator, and I'm curious, can you unpack that? Can you tell us a little bit more? Because it sounds like what you're saying is that Bottlerocket is designed to run in sort of a cluster configuration.
That is correct. So we've been very opinionated about Bottlerocket. So it is short of dev test scenarios. It is not something that we foresee or we recommend as a production use case to run a single instance of Bottlerocket. It is something that is optimized for running in numbers in a cluster, and a cluster where the containers that essentially host the workloads and the applications in that cluster are sort of scheduled and placed, and the HA properties around that are all provided by a container orchestrator. Examples include ECS, which is our own solution, or EKS, which is essentially a managed Kubernetes solution. Now, Bottlerocket itself is sort of container agnostic. It's not sort of joined at the hip to any specific orchestrator. However, it's still in preview right now, and as a point in time thing. It currently supports the public preview supports Kubernetes 1.15, Kubernetes 1.15, and we've also done a bunch of integration work to make it available with EKS. ECS support is being worked on. Like I said, it's a public GitHub open source project, and it's on a roadmap, and we're tracking.
We actually have a great question from chat. With the launch of Bottlerocket, is this aimed to be sort of the ideal operating system for containers that could be provisioned by something like Firecracker, for example? I know Firecracker spins up micro VMs though, right? So would Bottlerocket OSs come into play here, or are they kind of separate like separations of concerns?
Right now, I think there is a clear separation of concerns, but going forward, we do see an integration path. And let me explain a little more. So Bottlerocket is an OS that is intended to be run in either virtual machines, that is EC2 instances, or on bare metal platforms, such as EC2 bare metal. And containers are run on Bottlerocket. So it's a container host operating system. So this is the OS that hosts the container, because the container base images don't really have a kernel, and they're just base images that provide you the option to build up multiple layers on top. Firecracker, on the other hand, is a virtualization solution. So it's a technology that provides a virtualization host. So it lays down a hypervisor, and then it also provides a device emulation surface that essentially provides a virtual machine by essentially emulating some parts of a real physical machine in software, thus providing a virtual machine. Firecracker is special in the sense that the set of devices that it emulates is a much smaller subset of what, say, the most traditional virtualization platforms emulate, or the PCAT standard, or things like that. By removing sort of unwanted or sort of infrequently used devices, at least in the modern world, such as an emulated floppy disk, an emulated CD-ROM, etc. So Firecracker is currently a virtualization technology. Bottlerocket runs containers on top of an OS kernel. In fact, there's a shared kernel for all the containers running on Bottlerocket. Specifically for the purposes of isolating between those containers, Bottlerocket uses traditional container isolation mechanisms. So it is C groups or control groups in the Linux kernel for isolation, as well as kernel namespaces. In addition, Bottlerocket also uses SC Linux, security enhanced Linux, in enforcing mode to ensure security between the containers and the host itself. And this is the container, which is the Bottlerocket host. It also comes with this feature that's in the Linux kernel that's called DM Verity. So Bottlerocket essentially has an image-based update mechanism because it does not have a package manager. So each update is essentially a brand new image that is downloaded and you quickly reboot into. And that is signed and verified during its bring-up process. So if there is any inadvertent or intentional tampering in the process, that image does not come up. Now, there is a convergence path that we are exploring, and it is, if you pay close attention to our GitHub repository, you will notice that we are looking to explore the possibility of using micro VMs with Firecracker as an isolation mechanism for the containers that can run on Bottlerocket as an optional property. Now, if you look at this entire spectrum between user space processes and full virtual machines on one side, you get, on the full virtual machine side, you get great isolation, both security isolation as well as resource isolation. Maybe not as good when it comes to density, as good when it comes to startup times. The other hand, the reverse is true. Firecracker gets us to a happy middle ground, a sweet spot in that spectrum. Now, Bottlerocket certainly does not provide the same level of isolation, which is hardware isolation with VTX and VTD and hardware extensions that micro VMs provide, but it uses the kernel level isolation. Now we are looking at the possibility of using micro VM isolation or VTX based isolation for isolating Bottlerocket or containers hosted by Bottlerocket. That was a long and windy answer. Hopefully I was able to answer it sufficiently.
Well, Samartha, I think you omitted one interesting fact. One similarity between Firecracker and Bottlerocket is that they're predominantly built with Rust. Is that right?
That is correct. That is a fantastic point. So large parts of Firecracker, in fact, there's a sub-project in Firecracker called Rust VMM, which is a Rust-based virtual machine monitor, as well as large parts of at least the code that we've written from AWS for Bottlerocket are written in Rust. It is certainly it's a new programming language that helps sidestep and sometimes remove a certain category of memory related errors. So we at AWS are big fans of Rust, and the fact that we're choosing Rust as the preferred language for system software projects is testament to how much we're proponents of it.
Awesome. I wanted to dive a little bit deeper on these atomic updates, because that's one of the things that jumps out to me, right? Like at the operating system level, you're going to have typically some sort of just sequential set of installations that are happening to update your environment from the pre to post sort of stages, or stage 1 to stage 2, right? And people build mechanisms around that to try and either eject if it gracefully eject, or gracefully fail if that doesn't work. But this is sort of one of the first times I'm seeing this for environments at the OS level. Can you talk to us a little bit more? I know you mentioned that images are involved here, but like, what does it actually look like to perform these updates in Bottlerocket?
Certainly. So at a very high level, essentially, you can think of Bottlerocket as an OS that has two partitions. There's an active partition and a passive partition. So the active partition is the one that is actively being used. And the passive partition is where updates are downloaded in the background. And when you actually want to apply that update, it is essentially a flip of the partition, and it's effectively a quick reboot into the passive partition. And then the active partition is where the subsequent update is downloaded when one is available. So that is at a high level the basis for how it operates. Now, to be more specific, there is a protocol that's called TUF, which is again an open source project. So what Bottlerocket does is it implements the stipulations of that protocol, and our implementation of that is again written in Rust. No surprise. And that's how it makes that happen. Now, so this is the update mechanism at the granularity of a single OS. Now, again, to go back to to sort of the differences between Amazon Linux or a general purpose OS and Bottlerocket, there is no package manager involved. There is no sort of package dependency tracker. So the updates happen in a single step, and that is the whole OS image. Now, Bottlerocket is a beneficiary of the fact that, or this mechanism here is a beneficiary of the fact that Bottlerocket is a minimal OS with just enough of software needed to run containers. So things like, say, the kernel, glibc, container runtimes, pieces to integrate with the orchestrator. Container Ds are container runtime itself. Might be missing a couple more components, but roughly it is super minimal. That's the high level idea, and as a result, it is the act of flipping between these partitions itself isn't too heavyweight to be able to reboot into this minimal OS. But this is sort of the update mechanism at the granularity of each OS. There is another update aspect here, which is at the granularity of the cluster. So you could have, for example, a Kubernetes cluster with multiple nodes running Bottlerocket. Now, we also have, we make this available through the Bottlerocket project itself, a Bottlerocket Kubernetes operator. And the purpose of this operator is to essentially allow users to perform a rolling upgrade of their entire Kubernetes cluster running Bottlerocket nodes. And the way that works is, let's say you have a cluster of 4 nodes, perhaps. So it goes to the first node. There might be containers running on that node. So what happens is those containers are moved to a location where there is more capacity. And then the update itself is performed on that specific node. And that update itself is a single step update. And like I mentioned, there's also the possibility to roll back that update, which again it doesn't have too much of a precedent in the general purpose OS world. Now, once that is done, once that node is updated, containers are rehydrated back. Then we go to the second node, repeat the process, and that rolling upgrade process essentially can be orchestrated with an orchestrator artifact, in this case, a Bottlerocket Kubernetes operator. And that's how that's made to be. So there are two interesting parts: the update at the granularity of each node, and then there is the update across the cluster, and that's how both of those work.
You know, as you're talking through this, I think one of the realizations I'm getting out of this is that there's this kind of a critical point here, right? Because you mentioned that the operating system itself includes only the bare minimum of what it needs to be able to perform these critical operations of running container workloads. And that seems to have this dual benefit. On the one hand, it reduces the surface attack area so that this is a more secure profile that's running on the base OS itself. And on the second hand, you had alluded to, you know, the reason why this kind of update situation exists. You have configuration drift, updates that are kind of unreliable in production, is because of the complexity and the graph of dependencies for the different pieces of software running inside your package manager, right? And then when you have this kind of system that you're describing, not only do you have a smaller surface attack area, you also have a simpler, you don't need a package manager because everything is so simple, and then also updates are less frequent, right? So I think this is maybe a litmus test of what you're saying is, you know, running, let's say, Docker on a general purpose Linux distro, that distro may be getting updates constantly, and they may not be essential to what you're actually doing with the operating system, but you as a DevOps personnel, let's say, might not be able to make that call immediately. There's a lot of information to go through about what constitutes that, right? Whereas I think what we can say with Bottlerocket is that updates are higher signal and less noise to you. Chances are, if you see, you know, a semantic version update to Bottlerocket, something important, you're going to be able to see exactly how this means or what this means for your operations. So I think that's another very interesting point that you're bringing up when you have this kind of purpose-built operating system.
That is correct. That is a very astute point that you made, which is that in a general purpose OS, where there could be a lot of unwanted cruft and unneeded software, there could be a need to patch that unneeded software as well, and that also increases the frequency at which you will have to perform these updates, which are and not to mention the act of applying those updates in a general purpose OS, you know, is not as deterministic as one would like it to be. And yes, there is a dual benefit there. And in fact, there are other vectors as well. Two other important points to note are, one is that it also simplifies management, because sort of the update mechanism is simplified. You can, you know, there's one other, I'm digressing here, but there's a little bit more of a detail, which is that Bottlerocket also exposes an API, and essentially these integrations with the orchestrator take advantage of that API, and you can essentially use the orchestrator to be the agent that actually performs these updates. The second detail that is also noteworthy is that Bottlerocket is so very minimal that it does not even include a shell. So we are also in many ways sort of nudging folks towards the operating model where you don't install arbitrary software on the host itself that runs your workloads. Secondly, we are discouraging folks from being, you know, sort of connecting to production hosts and making changes there. So the operating model that Bottlerocket in many ways nudges folks towards to itself is also unique, and one that is tailored towards security and a bunch of best practices. Now, having said that, if one really wants to do certain advanced debugging or troubleshooting when there is a need for it, there's also this notion of an admin container, which contains which is essentially an Amazon Linux container that it contains a bunch of traditional Linux tools that you can run with elevated privileges for the purposes of this, for advanced troubleshooting when there is an absolute need for it. But the typical production use case with Bottlerocket does not, is one that does not involve interacting with a shell, and one that in many ways precludes folks from being able to directly connect into hosts and install things on the host and things like that.
Okay, let me see if I understand that. So if I want to SSH into a Bottlerocket instance, what I should actually do is spin up an admin container and SSH into the admin container. And the admin container automatically has a bunch of tools that I'm going to want to use for debugging and troubleshooting and that sort of thing, right? Does it somehow map in like the root file system as well?
The root file system is still read-only. but nevertheless, you can install. You can do things like, say, if you have to install kernel modules and things like that with your admin container. Also, it comes with a whole bunch of traditional popular Linux troubleshooting tools that you can use on the host.
All right, well, we've been going very deep on this, but as I've done to both of our other guests, I'm going to ask you if we can see it in action.
Certainly.
It's an operating system. What does it look like to run with? Can we demo maybe updating it?
Certainly. So I will caveat this by saying that OS demos are never glamorous, and this is especially so when the OS doesn't have a UI to show, or let alone even a shell. So what I will be showing is in many ways the ways in which it integrates with the orchestrator and some of the workflows involved with, for example, doing what you said, which is updating the OS from the orchestrator itself. So I'm just going to share my screen. Just give me one moment. So can you confirm that you can see my screen?
Yes. If you could
with
pump up
the terminal window.
Yeah, if you could increase your terminal size a little bit, that would be super helpful.
Certainly. Alrighty.
Perfect. Thank you.
So essentially, what we've done with Bottlerocket is is that we've sort of tried to make a best effort to integrate it as easily, or to make the experience to use it with EKS as easy as possible. Now, EKS Scuttle is an open source project, which is the CLI for EKS, and EKS Scuttle is the preferred tool for deploying, say, a cluster of Bottlerocket nodes. So what I will do here is I've done a bunch of pre-setup here a priori to configure EKS Scuttle and kubectl and tools like that. So I have this file myeksscuttle.yaml, which is a YAML file, and let me actually go ahead and show you that file, which is on another window. Sorry about that. Yeah, so I am sharing another window, and this should show you essentially the YAML file that I'm using to create my cluster. So this is a YAML file that is an input to EKS Scuttle that will automatically pull the latest Bottlerocket image and go ahead and create an EKS cluster with 4 nodes of M-file large, and there are a bunch of IAM policies attached to that. So let me get back to my terminal. Apologies again for the frequent hopping between screens, but
no worries.
I go ahead and create that. Now I've already run that command because it takes a while to go set that up. So what I'll do is I'll go say kubectl get nodes. So this should give me a list of nodes. So that command is already run. It takes several minutes to run. So I did that while Nikhil was still doing his presentation. So what you see right here is 4 Kubernetes worker nodes running Bottlerocket. Now, subsequent to this, so what I'll do as an example is I'm going to just go run, just to show you all, a container in this cluster of Bottlerocket nodes orchestrated by Kubernetes. This is essentially a BusyBox container. I'm just going to run that as a pod. So I'm just going to say echo hello world Bottlerocket. So there you go. That's an example of a container running in a Bottlerocket cluster. Now what I plan to show you, when we've gotten past that, is this notion of an update operator, and this is what I just told you all about, which is a Kubernetes operator that can help perform rolling updates across a Bottlerocket cluster. And for that, I'm going to apply. I'm going to do a kubectl apply on this Bottlerocket operator itself, which is again a YAML file. So again, I'm going to quickly switch back into my my browser window that has this has the contents of this YAML file itself displayed. So this is a YAML file that I'm going to apply with kubectl, which essentially is the Bottlerocket operator that will operate on this cluster. And it is important to note that there are really two parts to this operator. There is a daemon set, which is essentially an artifact that runs on each one of these 4 nodes, and then there is also a controller which will get deployed, and there is only one of that controller. Now, what happens with Bottlerocket is that the updates to Bottlerocket are sort of annotated, and this this mechanism here essentially will track some of those annotations and then see if there are pending updates, and if there are, go ahead and apply it. So what I'm going to do is I'm going to run this. Oops, let me switch my screen first. Getting back to my terminal window. Yeah, I'm going to run this operator itself. And the 2 key points that I want to allude to is sort of the last few lines here. So you see the control. So there's a controller, and then there is an agent, and both of these. So I just run this before, so it's saying it's unchanged, but it just got deployed. So the controller there's only one of that, and then there are 4 of these agents that are a part of this operator, which is 1 per node. Now, once this is done, I'll just confirm that this is actually running by showing you the number of controller deployments. So it'll say there's just 1 controller, but it should say there are 4 daemon sets, which is sort of the agent itself. So that is sort of the way this Bottlerocket operator actually works. Now, if I actually wanted to check this operator in action, I can go ahead and examine some of the JSON message exchanges, because, like I said, each of these updates with the update servers for Bottlerocket are all exchanged through annotations. So I have this sort of intimidating looking command that I strung together. This will just go explore some of those messages here. So you'll notice this JSON blob, and I hope that the colors are sufficiently visible. But you'll notice sort of a blob per node, and what you'll see is that this update available field is blank, and then there is a certain interface version and things like that. So what would happen is, if, for example, there was a pending CVE, and then we issued out an update for that. So this would, as a point in time thing, say that indicate that yes, an update is available, and then go ahead and actually apply that across the cluster with this mechanism in place. Now, since I started with an updated army, I'm not able to show that right now, but at the very least, what I wanted to show you all is at least the workflow and the processes involved with that, and to give you sort of an overview of some of the some of what's happening behind the scenes to make that happen. Yeah, with that, I'll stop sharing my screen, and yeah, we'll get back to video again.
Yeah, so I know that cluster was already updated, right? But like, for example, what would the update command look like for those nodes, assuming there was one available?
Certainly, in an ideal world, if you had deployed that update operator itself, it would sort of monitor for these updates itself, and when one was available, you can either manually triggered it, or you could just have it do it automatically. Is it would drain the containers that were running on it to another node where capacity was available, and then actually perform that reboot. And it's hard to sort of visualize that on the console itself, because in many ways the purpose of the OS is to get out of the way to the extent possible, and it's sort of hard to show that in a demo as well. But essentially, what that would look like would be a quick reboot into the updated partition, and then those containers would come back, and your workloads would continue to run.
Awesome. I know we mentioned, Rob asked the question before, like what is very similar between Firecracker and Bottlerocket, and he mentioned that they're built in Rust, but I want to go back to the fact that they're both open source, right? So
That is correct.
if folks want to view, contribute, or even fork Bottlerocket or submit PRs, for example, can they do that on GitHub?
Absolutely. In fact, we've sort of one of the things that we've done, which is also I think worthy of being called out here as a discussion point, is that with Bottlerocket you can actually fork Bottlerocket, make your own changes, and then release it as a Bottlerocket remix by you can say Bottlerocket remix by Nick, for example. And use that name and distribute your image. And we've given folks the ability to do that. Furthermore, in addition to just the source code for the operating system itself, we've also made available the tools that are required to test the OS, to build the OS from source, as well as release it and distribute it, also as a part of the open source project. There is also, we're maintaining a clear separation of concerns between sort of the AWS provided builds of Bottlerocket, which are optimized for use on EC2 and include sort of the drivers that are needed for optimal operation on EC2, as well as are covered by AWS premium support plans and things like that. But the open source project itself is out there, and we've seen external contributors make changes. In fact, this is not a hypothetical; it's actually happening as we speak, where we have folks cut PRs and changes are getting merged, and so it's open source and all of that community goodness in action.
So you're saying I can create a remix of Bottlerocket where I add SSH back in and a package manager?
Possibly. I'm not sure about what the rationale for that would be, what the benefit would be. But hypothetically, yes, why not? You could, if you had your own orchestrator, as an example, you could go ahead and build a variant of Bottlerocket that includes all of the integration components for that orchestrator. Or if you wanted a different container runtime, other than containerd, you could go ahead and do that. Or if you wanted a different version of the Linux kernel, we use kernel 5.4. Maybe you want a sooner version or an older version for compat reasons, you could go do that. Or if there are bugs that we're not fixing as soon as you would like us to, you can include the fixes and have your own remix of Bottlerocket.
That's very exciting.
Talking about making Bottlerocket work for me or work for Rob's SSH and package manager use case, for example, it just makes me think, we've launched Bottlerocket. I know that previous to the GA or the availability of new projects like this, we typically work hand in hand with a lot of customers to help develop these to solve their problems as well. Are there any customers that we know of that are using Bottlerocket out in the wild?
Certainly. So we have customer Viva, who we have a featured quote from them on our website and all of that. But yes, they've used Bottlerocket. There are a whole bunch of other customers whose references are yet to be public, who have been active participants in our private preview that we had running for a fairly long duration to elicit feedback. I mean, this was a very opinionated and a possibly risky path as well. So we did take our time to vet it with customers and elicit feedback and make a few tweaks based on that. But yeah, Viva is the largest one that pops to mind. So as a customer, and then there's also a plethora of independent software vendors, ISVs, who have essentially validated their software that is containerized for use on Bottlerocket. So there are folks like Alcide, Tigera, New Relic, and all of their APM agents. There is Armory. There is Datadog. I'm probably missing a few more, but a lot, and there are more in the works. Our pipeline is certainly of ISVs that we're working with is much larger than the ones that we've already worked with. And as we approach general availability, I'll still remind you, it's still a product that's in public preview. We're hopeful of working closely with more ISVs and ensuring that once we're GA, it'll unblock the roads for a lot of customers to use it in production. And going forward, we're certainly aiming for this to become the de facto and recommended OS for customers to use to run containers on EC2. and this is for the AWS provided builds, but also on outside of EC2 with the open source builds, and we're looking for we're noticing lots of exciting work regarding support for additional platforms as a part of that open source project itself.
Wonderful. Well, Samartha, you've been doing great. Before I let you off the hook, I've got one more question from chat for you. Viera01 asking, do you know what version of C groups Bottlerocket is using?
Not off the top of my head. It uses kernel 5.4, so likely the version that is in the upstream version of kernel 5.4. There is a lot of work that's happening in the C groups world itself with C groups 2. As some of that matures and stabilizes, we look to ingest some of that in as we roll newer kernel versions for Bottlerocket and Amazon. So.
Awesome. Well, again, Samartha, from the product manager for Bottlerocket, thank you again for the session, the deep dive, the walkthrough on actually using Bottlerocket and what that would look like to use with like the EKS operator.
Certainly. Thank you for having me.
Yeah, thank you.
It's great talking to you, Samartha. Thank you.
All right. Hang tight, and we'll be right back to close out the show in just a moment. All right, so we've made it through the show. This was a bit longer than the first episode, but we also had 3 times the number of demos. So I feel like we did a pretty good job, Rob. What do you think?
Yeah, this is so action-packed. I couldn't have asked for a more exciting lineup of demos. I mean, every single one of these, there's so much to explore here, so much to unpack. And to think that we had such a hard time going through all of the cool announcements that have accrued over the last 30 days.
Yeah, given a quick recap, I know lots of people have tuned in throughout the course of the show. Again, this is episode 2 of What's Next. In the beginning, we opened up where Rob and I covered some of our favorite launches. This week, we talked about Deep Composer, the machine learning powered music synthesis with a keyboard that's now generally available. We talked a little bit about, there were quite a few database-oriented launches. I spoke about Redshift and materialized views, how those are more valuable for downstream sort of BI and more efficient querying and storing of those results. And then Rob, you spoke a bit about Cassandra and Aurora.
Yeah, definitely. And then later on, when we got into the demo section, we saw a global data store with Redis. And I think what we're seeing is, this continued theme of extensive support for various sorts of data storage, data caching workloads on AWS. We saw with both the Aurora Postgres compatibility features as well as the global data store caching features that have very similar shapes in terms of standing up a cluster, managing that cluster for you, having the ability to take one of the read-only replicas and promote it into a write master, providing really low latency in terms of inter-region reads and then intra-region reads and then inter-region replication. So, and then also, of course, I can't emphasize how much work this is actually saving you. If you don't believe me, go and deploy one of these databases. I think like go and deploy MySQL, right? I mean, people love MySQL. It's very easy to get started with. Go and deploy a MySQL cluster across the world that spans the world with, write master and read replicas and, enough individual fault domains. You'll find that it's actually very challenging to do. And it's especially challenging to do when you have a lot of production data that's depending on this kind of workload, that's depending on the availability of this workload, right? And so it's extremely valuable to be able to have a service that can kind of do all of this for you and manage this all for you. So I think all of that is it's incredible for me to see, because this kind of stuff has not actually been around for that long, this kind of option, right? So that's always interesting to me when I think just how recently, there's something like this was just not an option. Even if you wanted to pay for it, you wouldn't get it.
Yeah. I know that when we think on the AWS side in terms of how we should prioritize and build out features, we try to think about the things that aren't going to change, right? That's something that Andy Jassy talks about a lot in a lot of the keynotes. Customers are never going to complain to us about making the access to their data faster, cheaper, on like a lower latency because we're bringing it closer to them, making it more available, making it more durable. And we see this recurring trend coming across all of our data-oriented storage products, whether that be warehousing with something like Redshift, or like Aurora, as you spoke about today. So some really awesome stuff there.
Exactly. There's never been an email that's like, "Dear Andy, my bill is too low. I would like to pay more for the same thing." But the other thing, I as we're kind of recapping this episode, I realized that we've kind of covered the entire stack, right? We've covered front end with modern web applications with Amplify hosting and the CLI. We've covered the API layer through the extension of Amplify covers that as well. And then right beneath the API, you have your caching solutions with Redis, we have your database solutions with Aurora, and then even down to the operating system level with Bottlerocket, and the exciting conversation we just had with Samartha. So I think this was we didn't plan this out, but it's almost as if we did.
Well, I think there are just so many launches, and when we're covering the most exciting ones from a month time span, in episode 1 we joked about trying to tie them all together to make a hypothetical shoe startup, with personalized email notifications for the pinpoint demo that we had there. Here, when I'm trying to string all these together, I feel like I have the makings of a CMS with data warehousing and global caching with data store, and then ties right into our second demo we had with Amplify, right? To be able to build and deploy and manage that CI/CD entirely through the console, and now with the CLI tying into that, making that even easier. And then lastly, sort of the out of left field Bottlerocket, right? A purpose-built container OS for running containers. Which has applications broadly across whatever you're working on, because anywhere you're trying to manage this, especially if you're working with Kubernetes or EKS or ECS here. But again, broadly, that's an open source operating system, right? Folks can fork that, they can submit PRs, they can sort of make it their own. But it's always great to see AWS pushing stuff out into the open source community that we know benefits us and we know will benefit customers and just developers at large.
Yeah, absolutely. Well, I think we're near the end of our time. For those of you who stuck through the whole episode, thank you very much for being here. We're going to try and bring you one of these episodes at least once a month, if not more frequently, right, Nick?
Yeah, again, one of the hardest parts about prepping for the show was talking about the things we wouldn't be able to bring onto the show and the deliberation around that. And so we think that maybe having this more frequency will remove the need to cut stuff out. We'll figure out duration and all those sorts of things. But at the end of the day, we're just happy to be able to bring you launches in another form that you otherwise may have missed, or to give you a deeper dive on launches that may not have been as available through a blog post, let's say. So looking forward to the next few episodes.
Right on.
All right. Well, we've got a new little tradition here in episode 2. We're trying it out for the first time. So I'll be watching chat to see how you all like it. But obviously, Rob and I can only cover a small subset verbally and visually on the stream. But we have worked very closely with our producer here to get you a nice little rolling credit shot at the end with all of the launches from March. So with that, I think Rob and I are going to be signing out. But stick around for the credits, and that will show you all the launches from March. So without further ado, here we go.
And please fill out the feedback survey if you want a chance at some AWS credit codes. I think we have a link to that in the chat, right?
Yep, we will get that thrown in right as we are rolling the credits. So thank you again, everyone who's tuned in, and we will see you on the next episode. Have a great day, everyone.
Signing off. Bye, everyone.